All right, so finishing up from yesterday, this is 5.5 day 2. Did we start this one at all? No, okay. So we start sketching our angle. The given angle is 43.1 degrees. Okay, and then what's the side opposite that? Okay, so we have 186.2 here, and our other side that we're given, the 248.6. Okay, and remember yesterday we talked about, don't worry about what angle label they're giving it, whether it's ABC, right? Always put it in that corner, and then everything is going to kind of look the same. You'll be able to visualize it a little better. So, is that 186.2 long enough to extend out and form exactly one triangle? For it to do that, it would have to be bigger than the 248.6, right? Or it could come straight down and be the height. Okay, so we have to check what is the height of this. How did we find the height yesterday? Okay, so the side next to angle A times the sine of angle A. So 248.6 times the sine of 43.1. What do we get? I heard 169.862. Okay, so is it long enough to be a height? Is it exactly the height? No, it's longer than the height, but it's still smaller than this 248.6. So this is that case where you can think of it being kind of a hinge and it's just kind of swinging back and forth. Okay, it can swing out and extend out to here, or it can swing back in like that. Okay, so we have to consider both cases. Everything else stays the same. This 43.1 degrees is still the same. This is still 248.6, and this side is 186.2. Okay, but we are going to have two different angles. So I'm going to call that B1, and I'm going to call this B2. This then will be C1, C2, little c1, little c2. Okay. Do we have an angle and its opposite side where we know both values? Yes? Which one? The angle A, side A? Okay, so we can use that in our law of sines proportion, and can we use that then to find angle B? Okay, so the sine of angle B sub 1 compared to its opposite side, 248.6, has to equal the sine of angle A, which is 43.1, compared to side A, 186.2. And how did we solve that yesterday? Okay, cross multiply. So the 248.6 is going to move up to the other side. And then what? Then we have to use inverse sine, right, to figure out the angle itself. So angle B1 would be the inverse sine. The 248.6 is going to move up, get multiplied to the other side, times the sine of 43.1 divided by 186.2. All right, use your calculators. Make sure you have them in degree mode. What are we getting? Anybody? 65 point. Okay. We good with that? All right. Now, some people like to find angle B2 right away on the other triangle? Some people like to finish the first triangle before they move to the second. Doesn't matter to me. Do you have a preference? Finish the first one. Okay. So we now know this angle. Can we find angle C1? Okay. How do we do that? Okay, so 180 minus the given 43.1 and the new one we just found 65.819. What do we end up with? 71 point. Okay. And then the last piece is to find side C1. So we say the side C is to the sine of its angle as what? 186.2 is to, good. Okay, so this one just involves multiplying that sine of 71 over to the other side. What do we get for C1? Anybody? What'd you get, Alex? Agree, disagree? Yeah? Okay. So we finished the first triangle. Now if we go back, yes?
What did you have that equation there? Where did you flip-flop how you had it set up on your solving for angles?
So the first day, let me flip back to that screen. It's over here somewhere. There we go. Proportions, remember you can take the whole proportion and flip it over. So if I'm trying to find an angle, I'm going to use this version, okay, because I want the angle on top. What I'm solving for, I want in the numerator position. If I'm trying to find a side length, I flip the whole thing over and I put the sides on top. As long as you keep them the same, so you have angle is to side as angle is to side, or side is to angle as side is to angle, as long as you keep that the same, it'll work. Okay, so looking at the alternate triangle, this side swung, is that a word? Swung back in, okay? If it had been outside, like the first picture, these angles would be the same because you have an isosceles triangle. Yes? So if we found this angle to be, what was it, 65.819, then this angle here is 65.819. And how can we find the inside angle B there? Right. So angle B2 is simply 180 minus angle B1. Which is what? 114 point. Okay. And from there, it's the same that you did on the other side, right? You're going to go through now, find angle C2. You're going to have to take 180 minus the two angles you know. So 180 minus 43.1 minus 114.181. What do we get? Okay. And then to find side C2, set up our proportion. Okay. So side C is to the sine of 22.719 as 186.2 is to the sine of 43.1. What do we end up with? Anybody else get that? Okay. So where are we at with the two triangle situation? I know it's more work, but do you understand the process? Okay. So what situation leads to the two triangles? Side-side angle, when the side opposite the given angle is smaller than the other given side, but bigger than the height. Okay? That's where you end up with it being able to swing back and forth and hit in two spots. Okay. So we are moving on to a couple application questions. The first two pictures, or the first two examples have the pictures drawn for you. The next two, you have to create the picture. And that's typically where students have a little bit of struggle because they're having a hard time visualizing it. Okay, so as we read through these first two, I want you to be very clear why the picture was drawn the way it was. Okay, so that you can do them on your own. It says, Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction 32 degrees east of north. Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. Find the distance from each ranger station to the fire. Okay, so let's go back through and look at our picture. At Station A, it says they sight the fire 32 degrees east of north. So instead of going straight north, we have turned east 32 degrees. Does that make sense? From point B, Ranger Station B, same idea. Instead of going straight north, they had to turn 48 degrees towards the west to see the fire. So does that make sense how the picture's been drawn? They also said that the two ranger stations were due east, like Station B is due east of Station A, so straight east, and they're 10 miles apart. The two angles they gave us were on the outsides of the triangle. Can we find the ones on the inside? What do we know about this? That's 90 degrees because it's due north, due east, right? That's a 90-degree angle. So if we've used up 48 degrees, what's left for angle B? Okay. And on the other side, we used up 32 degrees. What's left? Okay. Does that make sense? Do we have the side-side angle situation where we have to worry about, does it make one triangle, two triangles, no triangles? No. What are we given? We have an angle 58 degrees. We have a side right next to it of 10, and the very next angle 42. We have angle, side angle. Okay? This just creates one triangle. We don't have to worry about option B. Okay? So, do we have a pair where we know both the side and the angle opposite it? Okay, no, but we can get one is her answer, right? Can we find angle C to pair up with side C? Yes. Okay, so that's our first step. Angle C would be 180 minus the two we are given. What do we get? Okay. All right, so they asked us to find the distance from each station to the fire. So let's go and start finding side A here. A is to the sine of 58 as 10 is to sine of 80. Okay? How would we set up if we were trying to find side B? B is to the sine of 42 as, okay, So in both cases, we have a sign that needs to get multiplied to the right side. Yes? Okay. So once you've done the first one, you should be able to just recall it and change that 58 into a 42 without retyping the whole thing. All right, go ahead and find your A's and B's. All right, what do we get for A and B? Okay, now, what was the question they asked us to find? So for station A, how far is station A from the fire? It's opposite, right? Because the distance from station A to the fire is actually labeled side B. Okay, so just be careful when you go to answer it that you go back to your picture and make sure how you labeled it. Okay, so station A is B miles, 6.9795 miles from the fire. And station B is 8.611 miles from the fire. Questions about that one? Okay. Example 5. It says a road slopes 10 degrees above the horizontal and a vertical telephone pole stands beside the road. The angle of elevation of the sun is 62 degrees and the pole casts a 14.5 foot shadow downhill along the road. Find the height of the telephone pole. Okay, now we have some issues because the road is not horizontal. Okay, it's at a slight angle. So it says it's angling up like this. So if your telephone pole, if this is the road and the telephone pole is vertical, you don't have two 90-degree angles, right? It's offset. How big would this angle be? What was the angle of the road? 10. So we've used up 10 degrees, right? So this is only 80 degrees. This other angle has the full right angle plus the extra 10 degrees, right? You're taking 10 degrees off on the right and putting it on the left. So this angle is really going to be 100 degrees. So it still makes the 180 linear pair, right? They're supplementary angles. It's just you don't have 290. You have an 80 and a 100. Does that make sense? I see some puzzled looks. Are we okay with that? All right. So looking at my picture, this is my 80-degree angle here, which means angle B here is the 100 inside the triangle. Okay. So looking at triangle ABC, the pole is vertical. The base down here is the shadow. What did they tell us about the shadow? Okay, so the sun is up here, right? Casting a shadow down the road. So this is 14.5 feet. Now, we need to find angle A because we're trying to find side A. So we have to pair those up. Angle A is similar to the 62 degrees, but not quite. Again, because the road is slanted. Okay? So if this angle of elevation to the sun, from horizontal looking up to the sun, okay, was 62 degrees, that means from horizontal, down here, from horizontal looking up would be 62 degrees. But we aren't horizontal. We've cut off 10 degrees of that. So angle A is really only 52 degrees. Okay. All right, let's clean up our picture a little bit here. Okay, so we had 14.5 and we have a 52 degree angle there. So we have a triangle with 52 degrees, then side 14.5, and then a 100 degree angle. So we have angle, side, angle. Okay. Do we have a pair that's known? Angle and side. Just the way it's labeled right now. No. Can we find one? Yes. So what does it mean we have to do? Yes. We have to find angle C. So 180 minus the 52 and the 100. What's 180 minus 152? All right, so finding side A. A is to the sine of, good, 52, as is to the sine of 28. All right, take a minute. Use your calculators. What do we get for A? What did we get? Say it again. 24.338. Check yours. Okay. All right, so the height of the telephone pole is 24.338 feet. Questions on that one? Okay, so the next one is very similar to one of the two we've just done. At your tables, I want you to sketch the picture. All right, let's check. I looked around as you were working on this one. You've got towns A and B. The one thing I did clear up with a few people, angle of elevation is from horizontal looking up. Okay, so from horizontal here looking up was, what was it, 60 degrees? And on the other side, 75 degrees. And the two towns are 340 miles apart. And this is your satellite? Yes? Okay, so finding sides A and sides B, it's kind of like the fire problem, right? The two fires, or the one fire from the two stations. So side A is to sine of 60 as 340 is to, okay, so we had to find angle C, right? Okay, so angle C was 180 minus 60 minus 75, or 45 degrees. All right, so what do we get for A? 4, 13. Okay. And then for B, B is to the sine of 75 as using the same ratio.
Yep.
340 is to the sine of 45. And you got B to be 464.449. Okay, so again, to answer the question, how far is the satellite from town A? So the satellite is 464.449 miles from town A. And it is 416.413 miles from B. Yes? Okay. Our last one. It says, to measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance of 3,000 feet apart at the same elevation. The first observation results in an angle of elevation of 48 degrees, and the second results in an angle of elevation of 35 degrees. If the transit he used to measure the angles is 5 feet tall, what is the height of the mountain? Okay, so first of all, picture a mountain. Everybody have a mountain in their head? Okay. We're trying to measure the height, so we're looking at going from the peak down through the center, right? Okay, so here's our mountain, and we're looking for that. Okay, now, we are told that they measure the angle of elevation to that peak from 2 different spots, okay? So if we come out here from 2 different spots, angle of elevation from one versus angle of elevation from the other. How far apart are those 2 spots? Okay, so this is 3,000 feet, and we'll just label this A and B. What would the angle of elevation be for point B? How do I know that's the 48 one? Right, they gave me 2 angles. Angle of elevation is 48 and 35. So my question is, how do I know this is the 48 and not the 35? Right, the closer you get to the center, the bigger the angle is. So this would have to be 48 degrees, and this one would have to be the 35 degrees. Are we okay with that? All right, now, here's the problem. We are trying to find that distance, right? The height? Yes? Did they measure from ground level? No. They said they were 5 feet up, right? The transit sits 5 feet tall. So we actually have an extra little 5 feet down here. Okay? We can add that in at the end. But right now we have 2, well, actually 3 different triangles we could look at. We have the little triangle, all right, from our right angle to point B and up to the peak. I'll label that C. The problem is we don't know any of those sides. Okay, so we can't use that little angle. So let's go out to the second angle here. This one here. Okay. Do I have enough to figure out my missing sides? A lot of students want to use the very biggest one, okay, including the right angle all the way out to point A and up to point C, okay? Because they say, well, I could just do SOHCAHTOA, right? It's a right angle. I can get my height that way. The problem is we don't know the whole base. That 3,000 is only the space between points A and B, not all the way to the center of the mountain. Okay? So what we're going to have to do is we're going to have to start out using this triangle and find one of our sides. Okay? So we could find that side, we could find that side, and then go to the big triangle and use that. Okay? So let's say we find side A. I'll label that one side A. Do we have an angle and its opposite side figured out? What? It can be done. It's not labeled right now, but we can figure it out. Okay, so how about this angle here? How do we know that? It has to be 180 minus the 48? Okay, so angle B is going to be 180 minus the 48, which gives us, okay, so this angle is 132. Can we now find the little angle C at the top? What do we get? Okay. So to find side A, we can say A is to the sine of 35 as 3,000 is to the sine of 13. All right, go ahead and find A. Hang on, let him check. Let him do it. Thank you. You need to take 3,000 times that, divided by that. So it's not that. Do you have it in degree mode? Mm-hmm. Were your other ones working? Mm-hmm. Oh, 35 degrees. Sorry. We're finding side A.
I did that one up here, right there.
Oh, okay. That's all you need. You don't need side B.
Oh, okay.
Okay. All right. So what did we get for side A? 7649.35? Okay. So if we know side A, and we know that 48-degree angle, so I'm moving now to my little right triangle piece. Okay, this was 48 degrees, and we just found this side to be 7,649.35 feet. Can we find that side? Okay, so now we can just do our SOHCAHTOA. Which trig function would we use? Sine? So the sine of 48 degrees equals x over 7649.35. Okay, so multiply that over to the sine of 48. What do we get for x? 5,684.575. Okay, is that my answer? Okay, remember when we talked about the transit being 5 feet tall? So we found from here to here, and we now have to add the extra 5 feet to get the total height of the mountain. All right, so we're going to add 5 feet. Questions? All right. So there's your assignment.